Now, second numerical. A book of mass 1 kg is raised through a height h. If the potential energy increased to 49 joules, find the height. It's a question. So, a book of mass, say this is the book, this is the mass 1 kg is lifted up to a height h, and potential energy is given to you. Potential energy equal to 49 joules. Now you ask you to find what is the h value. You know, here you take g equal to 9.8 meters per second square. Now write the formula. Pe equal to mgh. Pe is 49, mass is 1 kg, g is 9.8, and h you have to find. Now 49 by 9.8 equal to h. 9.8 taken to the left hand side. Now 49 2s are 9.8, as 9.8 is 0.2, so implies h equals to 5 meters. Okay, now this is special information I want to give you in conservation of energy, in the conversions of energies. One is simple pendulum and the second one is freely falling body. Let us first we start with simple pendulum. Conversions of energies or conversion of energy. A simple pendulum is nothing but a bob, a metal bob or a metal sphere connected to a massless thread and suspended from a rooftop, and when you pull the bob to one side and leave it, the bob starts oscillating. Now, this is called simple pendulum. So in the simple pendulum, if you see, when the bob is at rest state, this is called mean position. When you pull the bob goes to certain height. See, this is the height h from the ground. This is the ground level, and this is the height h. The bob moves from the ground point. So this point is called extreme position. This is also extreme position. Now, whenever the bob lift to the extreme position, means the bob is moving to a height h. Any body is at a height h, the body has energy called potential energy, because P equal mgh. So it is at a height h, is potential energy. So when the bob moves from this point and going down, coming down, what happened? The bob's velocity keep on increasing. When it comes to initial position or the mean position, the velocity is maximum. When the velocity is maximum here, it has kinetic energy. And after that, it moving up. When it's moving up, its velocity decreases and goes to maximum height. And when it goes to maximum height, again it has potential energy. So, whenever the oscillations of a pendulum is happening, the pendulum is converting the energy from Pe to Ke, Ke to Pe, and vice versa. So this is one good example for conservation of energies. Example 1. Now example 2. A body is falling freely to the ground. Say take some points A, take some point B, C. This body or the ball is at a height h at point A. Whenever a body is at a highest point, its velocity is 0. When the velocity is 0, it do not have any kinetic energy. As it is at a height h, it is having potential energy. So this ball has potential energy. when the ball is falling down freely, its velocity keep on increasing, and when it touches the ground, it touches with the maximum velocity. So at point B, it has kinetic energy, maximum. Has maximum velocity, maximum kinetic energy. Then what happened to C? At C, the ball has not maximum kinetic energy, and at C, the ball has not maximum kinetic energy, but it is having some part of potential energy, some part of kinetic energy. So here it is PE plus KE. But this PE, which is equal to total energy here this is total energy, here it is total energy. So what I want to say that, suppose the total energy is 10 joules. 10 joules. At the highest point A, the ball has total energy 10 joules, but in the form of PE. At the lowest point, the ball has again total energy 10 joules, but in the form of KE. So energies are same, but the formations are different. According to conservation of energy, I told you, energy change its form, one form to the other, but the value always constant. At C, if you see, again the total energy 10 joules, but the 10 joule is shared between PE and KE. So energies may change, but total energy always remains constant. So this is another good example for conservation of energy as well as conversions of energy.